Good evening to all of you. Last class in complex numbers, we discussed how to find the square root of a complex number. Today we are going to discuss about polar form of a complex number, and we will do some problems related to that previous concept too. Okay. We will start our session. Let's polar form of a complex number. Complex number, or it can also be called as mod amplitude form. Amplitude is nothing but try to understand it is argument of a complex number. For example, this is my y-axis, there is an x-axis. I am taking point in orthogonal plane. Let's I'm denoting by the point as P, whose coordinates are a comma b. If I will join point P to origin, this will give you the modulus of the complex number. That is, suppose I am taking as R. Now, if I draw a perpendicular from P2 on positive x-axis, it touches x-axis at certain point. I am taking that as M. Now, it makes an angle theta in the anti-clockwise direction. I am denoting by theta. Now, can I say that O2M is nothing but A and P2M is nothing but B? Why? A is the distance of M from O is on x-axis. So, our x-coordinate is A. And PM is the distance on y-axis. So, our y-coordinate is B. So, we can denote it as PM equals to B here, OM equals to A. But here, try to understand what is R. R is nothing but what? Square root of A square plus B square by using Pythagoras theorem. But square root of A square plus B square is nothing but what? Modulus of Z. We discussed it in earlier. Clear? Theta, here theta is argument. Theta is argument, or we can say it as an amplitude. Now, observe here from this triangle OPM, can I say that cos theta is nothing but adjacent side OM upon hypotenuse, that is OP. So OM equals to A, OP is denoted by here R. So can I say that A equals to R cos theta? Similarly, sin theta equals to opposite side, that means PM upon OP. What is PM value here? B upon R. So can I say that B equals to R sin theta? We know that Z equals to, observe very carefully, R cos theta plus iota times R sin theta. Why? Because Z is nothing but what? A plus iota B. Am I right? So what is our A value here? R cos theta. What is the B value here? R sin theta. Just I replaced A value and B value in general form of complex number. Can I write it as Z equals to, if I take common R, I will get cos theta plus iota sin theta. But R equals to what? Modulus Z. So can I write it as Z equals to modulus Z times of cos theta plus iota sin theta? This is polar form of a complex number. I hope it's clear. Now, Let's see. Find or write the polar form, the polar form of z equals to 1 plus iota. So what is given here? Given z equals to 1 plus iota. Here compare with z equals to a plus iota b. What is a value here? 1. B value what? 1. Here a is greater than 0 as well as b is also greater than 0. So our angle is lies in first quadrant. We discussed different cases, case 1, case 2, case 3, case 4 in my last video. If you are not clear about that, please try to watch my last video, then you can understand easily. Now tan theta is nothing but what? B upon A. What is B value here? 1 upon 1, that is nothing but 1. So theta equals to tan inverse of 1. Tan inverse of 1 is nothing but 45 degrees. 45 degrees can I written as in the radians? Pi by 4 radians. But what is the polar form of a complex number? Polar form of a complex number, z equals to modulus z times of cos theta plus iota sin theta. What is mod z here? Square root of a square plus b square. What is our a value? 1 square plus what is our b value? 1 square. So can I write it as square root 2? Now replace the values. Therefore z equals to root 2 times of cos, what is theta? Pi by 4 plus iota sin pi by 4. It is our required polar form of z equals to 1 plus iota. You have to remember here, always the argument here you have to express in terms of radians. I hope it's clear. Now, here the polar form of a complex number z equals to what? Modulus z times of cos theta plus I sin theta, means iota sin theta. Clear? This is polar form. Now we know that cos theta expansion. Expansion of cos theta is what? 1 minus theta square upon 2 factorial plus theta raised to 4 upon 4 factorial minus theta power 6 upon 6 factorial plus theta power 8 upon 8 factorial and so on. In the same way, the expansion of sin theta equals to theta minus theta cube upon 3 factorial minus theta raised to 5 upon 5 factorial minus theta raised to 7 upon 7 factorial minus and so on. And also you have to know one more thing is the expansion of e power x. E power x expansion is nothing but what? 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus x power 4 upon 4 factorial plus up to so on. Here x upon 1 factorial is nothing but 1, so I am not mentioned very clearly. Now why I am explaining here? Observe, I want to replace this cos theta value in our polar form as well as I want to replace sin theta value in our polar form. Then what we will get? Let's see very carefully here. Can I write it as modulus z is nothing but r times of what is cos theta? 1 minus theta square upon 2 factorial. Observe very carefully plus theta raised to 4 upon 4 factorial minus theta power 6 upon 6 factorial plus up to so on. Clear? Plus iota times of iota times of what is sine theta expansion? Theta minus theta cube upon 3 factorial minus theta raised to 5 upon 5 factorial plus theta raised to 7 upon 7 factorial. Sorry, minus here, minus and minus up to so on. This is r into, that means this is r into the whole expression, right? Observe very carefully here. Can I write it as r times of 1, this theta, iota into theta? I am rearranging the terms just now. Iota times of theta, can I write plus iota theta? Next, minus, I want to make it as plus. When I make it as plus, but here actually negative is there. So can I write it as iota square? So iota square theta square. Iota square theta square can I written as iota theta whole square upon 2 factorial. I hope it's clear. Why? Because here minus theta square by 2 factorial, but I am making it as positive sign. When I am making it as positive sign, we know that iota square is negative 1. So negative of positive, negative theta square by 2 factorial. I am not changing anything here. Is it clear? Plus, similarly here minus, so I am writing plus. Can I write it as iota times theta whole cube by 3 factorial? Why? Iota square is negative 1. So negative into positive, negative iota into theta cube. So iota theta cube by 3 factorial. I hope it's clear. Plus, similarly, iota theta whole power 4 upon 4 factorial. Plus, iota into theta whole power 5 upon 5 factorial. Plus up to so on. If you observe that, it is quite similar to your e raised to x. Wherever x is there, in place of x, what is there here? Iota theta. So can I write it as simply now? That implies z equals to r times of e power iota theta. It is known as Euler's form of complex number. Euler's form of a complex number. I hope it's clear. So today what we discussed about polar form of a complex number, that is nothing but z equals to r times of cos theta plus iota times of sin theta, where r equals to modulus z. And we discussed about Euler's form of a complex number, that is z equals to r times of e power I raised e power iota theta. Clear? We will discuss some more problems in my next video. I hope these concepts are clear. Have a good day to all. Thank you.